Hi, I'm Guyulo. In our presentations, we will talk about ScyllaDB use case in the manufacturing industry. In more detail, we will talk about the sense data processing for manufacturing equipment. And we had many challenges through the pilot project about large data issues and compaction issues, and also lots of setup issues. We will show our solutions, how to solve those issues, and lastly, we will briefly introduce our ScyllaDB managed service, which is we are preparing to a public cloud.
Good afternoon, everyone. I'm Guyulo, data architect in Samsung SDS. Last year, I had a presentation about the POC result based on the ScyllaDB GA version. And today, I would like to introduce use case of ScyllaDB in manufacturing industry. Okay, my role in my company is planning and leading ScyllaDB project for Samsung. And my colleague Jungyeon is there, and he is leading ScyllaDB project for Samsung. My agenda is here. I will briefly introduce my company, who don't know well about my company. And I will introduce the use case in manufacturing. And we had several challenges through the project, so I will share about that. And also, I will introduce the ScyllaDB managed service, which is we are preparing based on our experience in about ScyllaDB and also DB operationals. Okay. Our company is an IT solution and service provider, and the main role is improving IT competitiveness for Samsung Group company, such as Samsung Mobile, Semiconductor, and heavy industry, and also financial companies. And our business area is divided three parts. First thing is IT service. And the next thing is business solution. And also, last our business area is logistics. And we are a global company. We have about 60 global offices and in 30 countries around the world. And also, we have offices in New Jersey and San Jose in US. We have a very close relationship with ScyllaDB. About 2 years ago, we had in-depth technical validations in the beginning of the ScyllaDB. Maybe 0.1, we had a POC based on the real business use cases. And after that, we are adopting ScyllaDB to our real business use cases, including manufacturing and also IoT platform and communication solutions and healthcare use cases also. And the early of this year, we signed a global partnership agreement with ScyllaDB to expand the business in a global area. And I already mentioned we are preparing ScyllaDB managed service in cloud, and I will briefly introduce the service in last sessions. Okay, this our use case system is called fault detection and clarification systems. This is a server system over MES, manufacturing execute systems. And FDC systems are gathering sense data from equipment in manufacturing plant in real time. such as temperature and pressure and some spec data, such as width, height, and those kind of things. And then FDC system analyze the data and monitoring the data. And if there is something abnormal data found, then FDC system stop the production line for enhance the yield. And actually, there is a legacy system, and all of the data, including metadata and transaction data and sensor data, are stored in commercial RDBMS, Oracle Exadata. But in this use case, we tried to divide the two categories. One is for RDBMS, for metadata into RDBMS, and another sense data will be stored to this ScyllaDB cluster. And these are the system requirements from our customers. Definitely, they want to high throughput, maybe more than 200,000 events per second. And definitely, Oracle Exadata can cover those high throughput, but the costs are very huge to pay. So they want to more lower cost than existing commercial RDBMS. And also, by increasing the business, customer want to scalability for production facilities. And another thing is about the easy deployment and maintenance. Also, easy to delete all the data. As you know, sense data is a very huge lot of data. So they want to delete using time to live, those kind of things. And we approached the phased approach because the transition system is not validated in real business. So we tried to adopt ScyllaDB to Korean manufacturing plant, and manufacturing capability is about in Korea about 5 to 10%, and more than 90% of manufacturing capability is located in overseas plant. And in the beginning of this project, customer want to have some comparison with Cassandra, which is the most popular column family NoSQL. And so we got the excellent performance data. Scylla has more than 2.3 times higher throughput, as you can see here. And at the time, we tested ScyllaDB 1.5 and against Cassandra 3.9. And the cluster is 30 node, and we developed the Java program as a client modules. And I already mentioned that there's a legacy system already in Oracle. And each sensor data is collected every second. And in the near future, the data will be collected in milliseconds. And the sensor in Oracle, sensor data occupies more than 80% of the disk. And also, there's additional columns. As you can see here, column 1, 2, step CD, blah, 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 and 19 columns are included here because customer want to have additional analytic to have some in-depth analytics. And this is the first design for ScyllaDB. And as you can see, we added a partition key as a daily partitioning. Mostly the customer are monitoring and analyze daily basis. So we added partition key daily keys. And we just, in the beginning, we just keep the additional 19 metadata columns, and we keep the default configuration about the ScyllaDB. However, we have several challenges during this ScyllaDB adoptions. First thing is, as you can see, adding additional 19 columns result in a huge amount of data. As you know, all of the columns in NoSQL stored the metadata also, so the data sizes are increasing exponentially. So our solution is defined user-defined type as a group of columns. As you can see, we added 2 user-defined type columns, and through the analyze the use cases. Through these solutions, we could find data size reduced more than 50%. Okay. The second challenge, we adopted at that time we adopted the data tiered compaction policy, but there's a ScyllaDB bug. In this compression policy, ScyllaDB cannot delete some expired data, and also some loop compaction happens. But we had a close collaboration with the Scylla team to solve these issues, and we patched it. And as you can see in this graph, the result was good. Expired data was deleted, and we could issue loop compactions. Thank you for ScyllaDB's team. They are very highly responsive and knowledgeable technical support. This is the other challenges we had, and in this morning, Abhi presented about the partitions, but we had large partitions, and it caused the size caused a very slow response. So we had some several spike POC, and we changed the daily key partition to hourly. Daily partition key size is about more than 34 megabyte, but in case of hourly partition key, size is about 1.4 megabyte. By changing this key partitioning, we could improve the response times. And also we implemented asynchronous 24 queries for one-day data in client program, and also we get 2 times faster reader latency through these our solutions. And the fourth challenge is about the memory. As you may know, if the size of a data DB file is 1.8 terabyte, and if chunk length is 4K, then compression input size will be about 13 gigabyte. But compression input DB should be cached in main memory, so it will cause some memory issues. So we changed the chunk length size to 64 kilobyte, and the compression input DB input size is about 0.8 gigabyte. So ScyllaDB team has a reasonable guide in their website, case by case. So it is very helpful for us. And after adopted these parameters, we could find the non-LSA memory usage decreased to under 1 gigabyte. This is the final design. I already mentioned that we changed the partition key and also developed asynchronous query program. And also we used the user-defined type columns, as you can see here. And we changed the chunk length parameters. This is the production metric. As you can see, the reader request and writer request is good, but the throughput is not greater than we estimate in the beginning of the project, because some equipment sense data is not adopted yet, but I'm sure the ScyllaDB can cover the required throughput that we expected. And this is also this graph also shows the react metric and disk usage metrics. Current data size about not great larger than we expected, but it will be increased soon. And also you can see the total disk size is not increased, and the compaction policy is working well. Okay, I will summarize the lessons learned from our phase 1 project. Data tiered compaction policy for time series data, such as sense data gathering, and it is very useful. And also UDT is one of our alternative choice for if there's many columns. And in many cases, the smaller partition size, the better. But in 2.0, they support low cache features, so it can resolve the partition issues. And also in client program, we could consider asynchronous API for fast range read latency. And also one of chunk size, suitable chunk size is one of consideration point for memory utilization. And this is voices from our customers. They are very satisfied with the simplicity of the architecture and also high performance. And but still, they require some enhancement features, such as new storage format to reduce the disk size, and also low cache to store incomplete partitions, and also hinted handoff and materialized view, and secondary index and time window compaction strategies. Some of the features are already implemented in 2.0, but also will be added in the near future. So we are happy for ScyllaDB's team's effort. Okay, I already mentioned this 3-node ScyllaDB adoption is phase 1's result. Customers are very satisfied about the phase 1's result. So we will have a close collaboration with the ScyllaDB team, and we will deploy it to overseas plant, which is more than 90% production manufacturing capabilities. And maybe currently we are estimated the ScyllaDB node will be more than 50 nodes. Okay, that's all about our use cases in manufacturing. From now on, I will introduce briefly about ScyllaDB managed services, which is we are preparing. And this is conceptual architectures. And as you can see, service provider, Samsung SDS will provide these kind of services through management interfaces, and also a customer can access through the consumer interfaces, self-service portal, those kind of things, and they will use ScyllaDB provisioning and ScyllaDB operations, monitoring, blah, blah, and the application developer can access the ScyllaDB cluster. And this is the features that we completed to implement. And I already mentioned that there's a cluster provisioning, DB operation, monitoring, and communication management, and backup and restore, and also scaling out. And also we will provide the data migrations and backup scheduler and this kind of optimization and DevOps features also. And about the optimizations features, we provide threshold management to give us some enhancement features for operating DB cluster, and also we provide some diagnosis features, kind of a health check, database health check functions, and also schema management, and we can execute the SQL query in our web UI. Okay, this page shows the features that we are implemented. This shows the provisioning screen. We choose many the packages in cloud environment, and this shows the node list, and you can see the status of each node, CPU, memory, LSA, and also you can see too fast, so I will. Okay. Yeah. This green circle shows one node. So we had a demonstration about 100 cluster, large-scale cluster to our customers. And this is a provisioning screen. And this is a node list, and you can execute each action, the node stop, the start action, and flush, those kind of things. And we provide a dashboard. You can monitor every metric that ScyllaDB is providing. And this is a small cluster that is using 30 nodes, and you can execute some command here. Stop the node. You can see the data circle shows the node is down, and we can execute the snapshot, and also we can execute the scheduled backup, daily based and once based, and those kind of things. And there's some metering data in the screen, computer usage, bandwidth usage, and DB usage also. Okay. And we will we will launch trial services on Joyent Public Cloud and Amazon Marketplace from next month. And you can install by yourself the trial services. And this trial service will be provisioned in your own infrastructures, and you can use these features by yourselves. And if you can give us some feedbacks, then it will be very helpful for us. Our managed service is called Kiroke. Okay, that's all about my presentations.